In the last lesson we discussed how to solve linear programming problems graphically, and in this lesson we are going to see how to use Excel solver function to solve linear programming problems. The solver function is available in the data tab, and you can see it somewhere here if it is already installed in our Excel. Here we don't see the solver function, and therefore we have to first install it. To install the solver function, go to the File tab and then Excel Options. Then from this list, select Add-ins. Now at the bottom of this dialog box we see this Manage Excel Add-ins. Click on this Go button and you will see the solver function is available in the list. Select the solver function and click OK. Now you will see that the solver function appears in the Data tab. Now let us take an example. This is a maximization problem. In fact, we solved this problem using the graphical method earlier, and if the solution is available, you can see whether we get the same solution. We need to solve this problem using solver. First, we have to write down the variables. Here we have two variables, x and y. Now let us allocate these two cells to get the values for x and y after solving the problem. That means the value of x comes to this cell, and the value of y comes to this cell. Then we have to enter the objective function z. Let's take this cell as the cell to which we get the objective function value after solving the problem. Here we have to enter the objective function as a formula in terms of x and y. So, start with equal sign, then 2 times x. X means the cell reference of x variable, so it is 2 times this cell plus 4 times this cell corresponding to y variable. Once you hit enter, you will get 0 as the function value, since we still do not have values for x and y. Now we have to enter the constraints. We have 3 constraints, 1, 2, and 3. In those constraints we have left-hand side and right-hand side. We have to enter the left-hand side and right-hand side of each constraint as a formula in terms of x and y. Let us enter the left-hand side of the first constraint. That is x plus 3y. X means the cell reference of x plus 3y means the times the cell reference of y. The right-hand side is 12. Then the second constraint, 2x plus y less than equals 16. That is 2 times the cell reference of x plus cell reference of y, and the right-hand side is 16. Similarly, we can enter the third constraint. Now the objective function and all the constraints have been entered, and now we can use solver function. Click on this solver and then you will get this dialog box. Here we have to set objective, and we have to give our cell reference to the objective function by selecting the cell like this. Then we have to select the criteria. Since it is a maximization problem, we have to select max here. If it is a minimization problem, then we have to select min. Then it says by changing variable cells. There we have to give the combination of cells that represents our decision variables. To give this, just select this first variable cell and drag it to the other like this. Now it says subject to the constraints, and there we have to enter our constraints. Click on Add, then we can add the constraints. Here you have to give the cell reference of the left-hand side of the first constraint. And then here you have to give the cell reference of the right-hand side. From here you can select the inequality, whether it is less than equal, greater than equal, or just equal. Since our constraint is less than equals, we will keep less than equals. Then click on Add again. Now the second constraint. left-hand side less than equals right-hand side. Similarly, third one, left-hand side less than equals right-hand side. Then we have two more, that is non-negativity constraints. Click Add again. Then select the cell of variable x, then select greater than equals and then type 0. Similarly, select the cell of y, greater than equals, type 0. Now everything has been entered. Then from here, select Simplex LP. Then click on Solve. And then click on OK. Now you will see the optimal solution here. X is 4.5, Y is 2.5, and maximum Z is 19. So, this is the way we use Excel Solver for solving linear programming problems. For the problems with unbounded solutions and the solution infeasible problems, the solver gives the corresponding message saying whether it is unbounded or infeasible. Also, there are problems with multiple optimal solutions and solver can recognize them. Unlike graphical method, Excel Solver can solve problems with more than 2 variables as well.